This is going to be our first inaugural and annual Space Day event at Western. Little did I know, I left right before coming to Western at the Canadian Space Agency. I worked at the Canadian Space Agency for 3 years, knowing that it was the John H. Chapman Space Center, but nothing there that I learned tied into London. And so I came to Western because it was rapidly becoming the center for space excellence in Canada. And I think it's a really nice closing of the loop, as it were, that we find that it's the beginnings of the Canadian space program, one could argue, begun here too. So our keynote speaker today is Michael Vergalla from Moon Express. Western's slogan is "Be Extraordinary," and I think Mike is going to be one of our most extraordinary keynote speakers that we've had. He has an undergrad and master's in engineering from the Florida Institute of Technology, has attended the International Space University and the Institute von Karman for Fluid Dynamics. He's published in various journals and conference proceedings, and he's the lead engineer for Moon Express, which, if you don't know, is one of the leading contenders for the Google Lunar X Prize. Michael's activities are broad, and he leads up the simulations, hardware testing, and design for Moon Express. Beyond that, he's an active member of the inaugural NASA's Student Association class, and Michael serves on its advisory committee and selection committee. So Michael and Moon Express in general are doing a lot of work and advocating for the young folks in the audience here too. He's also an avid outdoorsman, and we were just talking before this on the way over from lunch that many of us look out to space. Michael, I don't know if still is lining up to be an astronaut, but the more we learn about our Earth and our planet, it's a very special place in the solar system, and Michael is an avid paraglider and sailboat racer with many long-distance races to his name. So without further ado, Mike is, to me, the face of new space in the world. It's why I think space is so exciting, and I'm looking around the room at the young faces in the room, and maybe the older faces too. I think maybe 10 years ago that we would have if you would have thought back then, we'd have a company whose primary mandate is going to the moon and doing things on the moon and eventually bringing resources back from the moon. So we are in this era of increasing interest in space exploration, and I'll hand over to Mike.
Okay, cool. So, welcome to the future? No. All right, so I'm Mike Vergalla, and I'm a project engineer at Moon Express, but I would like to think I'm a lot more than that. I'm a life explorer, and I'll get to that in a second, but this planetary science and exploration, it doesn't say which planet, doesn't say whether it's Earth, doesn't say whether it's a planetary body, doesn't define that. So you better be practicing all this science and exploration every chance you get, every day you have, so that you're prepared for actually doing it when it counts and there's no oxygen to breathe. Okay, so we live on this Earth, and we are a civilization that consumes energy and produces waste. We're going to run out of resources at some point in the very long distant future. We can all debate about when that is or what that is or how those resources look, but we know that this is our only supermarket right now. This is the only place we're getting everything. Everything that we know that has ever existed has happened here, and in the last 100 years, we've sent a bunch of robots to Mars. But this is it. So what do? We kind of have to figure out how are we going to expand and take that next step and go as humanity to the next version of this. How do we lay the foundation for that? How do we lay the groundwork? How do we understand what to do about this problem we have? And the problem we have is that this is an island and we can run out of resources. But we have another island pretty close. And that island is approximately the size of another continent. And so we're looking at it as an eighth continent. And it's an eighth continent that doesn't have people. It doesn't have plants and natural resources that operations and mining could affect negatively. And what we've discovered over a number of robotic missions over the last 15, 20 years, even longer, is that it's not just a dead, dry rock. most people thought, well, okay, Apollo went to the moon, great. They found some rocks, they took some rocks back, and that's over. We haven't heard anything since. But the US had plans to go back to the moon. Politics made that not happen, but in those plans they sent a number of missions. They sent a mission in particular called LCROSS, which discovered water on the moon. And water on the moon changes everything. It allows us to refuel and continue. So we were talking today, what was the name of that road that goes up into Canada? The James Bay Road, okay? The most dangerous road in the world. And you want to know why it's the most dangerous road? Because there aren't gas stations. And it's a really long distance between the gas stations. Well, all of our planetary exploration is like the James Bay Road, except for there aren't gas stations at the end. So everything we do leaves from one place with everything we have, and goes to another place with everything we have, and goes back with everything we have. So we need to learn how to use resources on the place that we're going, and we need to know how to use those resources in a way that allows us to go elsewhere. Because only then will we really be able to explore into our solar system. So, Moon Express was created. Moon Express was founded by Bob Richards, Naveen Jain, and Barney Pell. To make it simple, this is the guy with the money, this is the guy who's crazy genius, and this is the visionary. So you mix these people together. This guy, we like to tell everybody how much money he has. He's got lots of money. But he has that money because he's not stupid. So he doesn't just give us a blank check. There was a previous project that tried to go to the moon called Blastoff. And that happened on the wave, the really positive wave of the internet bubble. And that was one person giving lots of money to a group of people to accomplish something. Well, what happens when that guy doesn't want to spend money anymore? That stops. So we've created a company. And our biggest challenge is how do we build a vehicle and make engineering progress at the same time that we build a company and establish a company that is capable of doing not just one mission, but many missions and establishing a foundation for exploration and data and transportation services to the moon. That sounds a little crazy. So you have to get the crazy genius, the crazy entrepreneur with a bunch of money, and the crazy visionary all together in one room and build a company. I bought a one-way ticket to California without a job and was the second employee at Moon Express. I did that because the budget got cut. And all of my jobs that I had prepared for and lined up for to work at NASA, that I thought that this is the thing to do, that fell out from underneath me. And what I recognized through the International Astronautical Congress and other things is that there was this new wave of commercial activity. And this new wave of commercial activity did it like NASA did it in the beginning, where they don't know what they're doing wrong. They just keep doing things. And what's wrong is when the company doesn't exist anymore. And then somebody else will look at that company and learn from their mistakes and move it that much further. So we've gone through a number of iterations. Our earliest iteration was similar, if you had been paying attention and collected the baseball cards of it, was similar to Odyssey Moon. Odyssey Moon wanted to come in, take a technology that had been developed by taxpayers, leverage that technology, and take the best of it. The problem is that that plan was perfect. It was a fast schedule, high cost, and a plan that we were pretty sure was going to work because it was technology that had been developed and tested. Turns out that plan cost millions of dollars a month once you press go. So you don't have a company anymore. You just don't have a company. You've run out of money. So that was an impossible plan. So we've gone over a number of plans, and our current baseline that we presented to the world in 2013, it's off the screen there, is this single-stage toroidal spacecraft, a flying propellant tank that can get itself all the way from a high Earth orbit to the moon. So this vehicle, I mean, we really, in space, if not everybody is engineers here, the most important thing is how much do you weigh fully fueled and how much do you weigh when you run out of fuel and how efficient are your engines? And that's the rocket equation. So we wanted to build a powerful stage that rides as a secondary payload. And the reason for that is, again, as a company, if I need to buy a rocket launch, that rocket launch is going to cost me anywhere from $60 million at its cheapest to $150 million if I buy the whole rocket. Now imagine telling an investor, hey, give me $100 million. I'm going to spend 60 of it just paying someone else, and I'll spend the other money on building technology and building value in the company. That's a really hard sell. You're basically saying, give me money so I can just pay someone else. So that breaks the equation. And so what you have to do is you have to say, all right, what is an opportunity where there's excess payload, or how do we make sure that every time when we get to this sense where we're wanting to run missions every 6 months or on a year center or just often, how do we do that? And how do we do that to where we don't care what the launch vehicle is, and we need to go on any launch that's going? Because it's not like a train schedule. These launches don't happen all the time. Everybody in the industry, they're aware of when most of the launches are happening. They're aware of who's on the launch, and they're aware of the courtship and the dance that happened beforehand and what payloads are associated on that launch. So we're designed to fit within a standardized ESPA ring, which is a payload adapter section. Imagine a tuna can. And we basically fit our whole spacecraft in this tuna can. It has enough delta V to go from high Earth orbit to the moon and land, which means that if it's fully fueled on the moon, it can come all the way home. This is good for our future that we plan. So we unveiled the vehicle, and our first mission is a mission where it's associated with the Google Lunar X Prize. Our first mission is basically to prove a commercial company can land on the moon. That is the first mission. A commercial company can land on the moon. You can buy everything commercially you need to crash into the moon right now. You could buy some solid rockets, you can buy all this stuff and mix it together and crash into the moon. But to land on the moon, that's really the hard part. Unlike the Earth, it doesn't have an atmosphere. An atmosphere is really helpful. Pressures tell us how high we are. The difference in pressure between dynamic and static tell us how fast we're moving. Well, on the moon, because of the way it's formed from impact craters, from really high up and really close, it might not look very different. So we need to know how fast we're going and how high we are. Otherwise, we're crashing into the moon. So this mission, we have a number of customers. We have a customer that's building a telescope that wants to send it to the moon. And we have Google Lunar X Prize as a customer. The reason I say it's a customer is that they will give us the money when we give them the video data of us landing on the moon, traveling 500 meters, taking video again, and sending all that video back. Okay? So that's a data customer. They're not giving us a payload to take to the moon. They're just giving us data. So this vehicle, part of the goal of the company is to enable planetary science and exploration. And how does that happen? If a government were to run a moon program, on the cheapest end, it might cost $300, $500 million to land on the moon, right? On the high end, well, in the US, it would be in probably the billions of dollars. That doesn't allow people to participate. That doesn't allow a small group of people in Nigeria to explore the moon. That doesn't allow scientists in Chile to investigate some geological features that they're interested in. So what we're trying to do is say, for the 5 or 10 million or even in the millions of dollars, individuals, academia, industry can pay for a payload on a ride. When you go and fly on American Airlines, you didn't buy the airplane, you just bought a seat on the airplane. And so think of it a lot like that, is where we're selling real estate, volume real estate and data service real estate, but we're selling real estate on our lander to be able to facilitate smaller groups to participate in planetary science and exploration. And that's really exciting because it means that a scientist that's worked their entire life on a laser reflector, for example, can finally get their life's work's next data set on our mission without having to get it approved by Congress, which, different crowd, but is hard. Okay. So this vehicle, with all of its delta V, what else can it do? It can get to the moon, but it also, we're imagining lots of other markets. CubeSat development, refueling satellites, collecting and moving space debris, and then also as a space tug. A lot of launch providers would like a restartable stage that was highly functioning and had lots of delta V. Well, everyone would actually really like someone else to build it and spend the money to develop it. When we develop this vehicle, we plan to have a configuration that can be used as a boost stage. And I'll get to some of the specifics of the vehicle. Right now, it's a hydrogen peroxide kerosene-powered vehicle. The central engine is the bipropellant engine, which is hydrogen peroxide kerosene, and the ACS engines, which are the landing descent engines, are just monopropellant hydrogen peroxide. So hydrogen peroxide, when you decompose it, is steam and oxygen, which it's a clean green propulsion system. Burning kerosene is not so green, but we say green in the sense that if I were to use hydrazine or other MON-NTO, it's got significant cancer hazards. It's really hard to test. It's expensive to set up the infrastructure. And so with hydrogen peroxide, we're able to set up test cells and test our own propulsion systems. So after we do this first mission, we have a second mission planned. And that second mission is to set up the first of a series of observatories on the South Pole. Scientists are really curious about going to the South Pole for a number of reasons. One, there's some areas where there's always light. There's some high mountain peaks. There's always some sun on it. You don't have to survive the lunar night. Another reason is that on the far side of the moon, not say dark, the far side of the moon, there's radio silence. All of the radio signals and everything that from Earth that we're pumping out into space and back and forth to our geostationary satellites, when you start to look on the far side of the moon, that doesn't exist. So the potential for advancement in radio astronomy is huge. And this is a precursor mission that's going to try to set that up. So at this point, we've done 2 missions to the moon. We have a vehicle that can be used as a moon lander as well as a kick stage. So what do we do next? Remember I said that this vehicle can come all the way home? Well, our third mission, we plan to build a scaled up version of the first vehicle, and the first vehicle is the payload for the scaled up vehicle. So we're on the moon now. We go and collect some regolith, either pneumatically or bucket drum or drill or however else. It's just a CAD image now. And then we bring it home. So we bring home 1 to 2 kilograms of lunar material as a little metric. Bill Clinton's moon rock, which was 3 grams, is worth $10 million. Okay? So what does this become? 1/2 kilogram of lunar material in the first couple missions, selling to private collectors. De Beers has plenty of diamonds, by the way. Selling to private collectors, you're able to pay for your mission and the next mission. So that's not a market that will exist forever, but it's definitely an early market that we need to take advantage of, because the only moon rocks that exist are within government hands, and I guess one of the students here has some samples, which is awesome. So we're interested in a number of markets, and we need to be careful, because as these markets change, we have to understand how to adapt to that. In the very early ones, there's going to be a lot of publicity around, yes, look at commercial companies landing on the moon, get excited, put your logo on it. But that's not a sustainable market. The real market is laying the foundation, establishing a port, and making it easy to go back to the moon and continue going back to the moon. I've said this example to a number of people today, but basically, when people all of this, everything that we have, all of London and all of the Americas, were because a bunch of crazy people got on boats and sailed off into the ocean, not knowing that there was land, not knowing about hurricanes, not knowing anything, not having enough food. A couple people survived eating their belts and their boots, and that was a great success. So in order to make the next step into the future, some people have to be a little bit crazy, and I'll be one of those crazy people for you if you like. And so that's how we're going to really make changes, being a little bit crazy, a little bit out there, and just going for it. Because it turns out no one else has contacted the FCC and said, well, guess what? How do I get a radio license for planetary missions for a commercial company? There's no checkbox to check. So anybody that comes after us, at least that FCC person that says, oh yeah, you know, I worked with Moon Express and we did this thing. But right now, there's no commercial band that we can purchase to be able to communicate from the moon back. So how are we getting to the moon and what are we doing? Because I don't want to just talk about it and show you CAD. So this image you may have seen if you paid attention to Odyssey Moon, but this is the common spacecraft bus, which the idea was to be able to quickly and rapidly make a spacecraft for any application. It could be a lander, it could be an orbiter, it could be anything you wanted. It doesn't matter because it's made out of composite sheets and you put it together really quickly. it's not an optimized spacecraft. So the engineers that built this were a little frustrated by it because it wasn't perfect for being an orbiter, it wasn't perfect for being a lander, it had extra mass in it to make it strong enough to be a lander, but that it was an orbiter. So this was used as a demonstration to win the Laddie mission at NASA Ames. But we took it over, and my first job at Moon Express was rebuilding this vehicle and getting it running again. So this was kind of our first training into how do we fly a moon lander. My work involved with redoing the energy crushables on the legs and repairing the composite frame that got structurally damaged when NASA crashed it. Okay, so next what did we do? So we graduated from that vehicle. That vehicle was powered by compressed air tanks. So these are just basically like scuba tanks with compressed air. So this was really nice because it took about 45 minutes to refill the tanks with our scuba compressor. And during that time, we could look at the data and try to figure out, okay, what's the next test we want to run? How do we continue this test series? And you can do a number of tests in a single day. We graduated to working with Marshall Space Flight Center with their Mighty Eagle. Now, this Mighty Eagle vehicle is powered by hydrogen peroxide, so you're starting to see the connection to us. And it's all monopropellant engines. So this guy, Jim Cady, he had worked on the Mighty Eagle early on when they had first started developing it. And the vehicle I just showed you before, I think we tested it maybe 12 or 15 times before we were free flying. We flew this the third time we were allowed to test. We free flew this. And that's starting to be a little crazy, right? So we were able to convince NASA that, yes, you should give us the keys to this vehicle and let us fly it. So the first one, they just let us ride, like in The Simpsons, I don't know. The Simpsons, Maggie is trying to drive the car. Anyway, we just drove, but nobody was listening to us. The second version, we were tethered, and they let us do a small little flight about half a meter or so. And then finally, they took off the tethers and let us free fly it on the third attempt. That's unprecedented. No one has ever been given a NASA asset as a commercial company and just allowed to fly it. So this is starting to, now you're starting to see that this snowball is gaining momentum. And we didn't crash it, so we decided that we would build our own test vehicle. Part of this was because there was terrestrial milestone prizes in the Google Lunar X Prize, but we decided we needed to build a vehicle. We needed to not spend money out of house. We needed to build value in our company. We took on the structure. We're now taking on structures, avionics, propulsion, every system we can possibly take on and bring in-house, we're bringing in-house. SpaceX has done that, and that's been it's worked out well for them. However, bringing everything in-house means you have to do everything yourself, and you can't blame anybody else for it not working. So this is a really, really exciting part of the project and of Moon Express as a company, because this is really showing people that we can build a flying vehicle. But we are always looking for innovation, and we had to associate this vehicle to the moon vehicle that I showed you. And you see that this looks a little bit like a donut. Well, it's not a toroidal tank. We found out that building a toroidal composite pressure vessel is way harder than we had originally thought of. But we still needed to make that connection. And so I found a sailboat maker in Santa Cruz, and he made us the composite shell. And it was fantastic for its purpose. It's not space composite, but it helps draw the connection between the two. Another thing that we built completely, well, the actual one is over there, but we built a telescope for a private customer who all they want is to share views of the galaxy from the moon to the rest of the world. That's what they care about. And it's a private individual who decided to spend their own money on this. And these are pictures that we took with the telescope, which are my screensaver because I think they're so cool. I'm not going to start to name them because I'll be wrong. But anyway, so we did this, our design cycle, we had structural analysis. So this is where I kind of come in, structural analysis, dynamic, thermal analysis, to make sure we delivered a good product. So I'm going to show you a video of our test flight. These originally were placeholders for sliding through the slides, but we have to tell this story. And we have to tell this story through animations and graphics. And I can explain to someone that we're going to go to the moon and lay a foundation for the future of humanity. But there are people out there that think there are trees on the moon. And I'm not joking. Someone asked me, are we going to hurt the trees? So people just have a lack of understanding of what the moon is, and it sure helps. A picture says 1,000 words. So here's a bunch of pictures and thousands of words. So I'm going to show a video. That is not the one. Oh, good, you don't get the music. Okay, so imagine really tranquil music, lovely. We were beginning adventure. The Honorable Dr. Bob Richards made this video. Oh, so now it's really intense music. So we're testing our vehicle where the shuttle used to land, which is really cool because when you go to test it, you have to drive down the shuttle runway, and the width of the shuttle runway looks like a normal runway. There's Buzz Aldrin and Bob. So we had to do this demonstration flight for the GLXP judges, and some of the judges are pictured here. So we did static firing, and then we did some pre-flights. So the steam is not completely combusted, and it's in order to heat up the catalyst packs. This is that animation on the moon. So we're flying this vehicle right now on a tether, and we plan to, in the next couple months, fly it without a tether. The tether was just so we don't break our vehicle. But it's stable. It's going up. These are all good things. So, okay. That's the video. And now, okay, what's my role at Moon Express? I was the second employee, so kind of means I've done everything from sweeping the floors to going out and getting lunch to moving. I mean, I think in the first 6 months we moved 8 times from different offices because we were taking up offices and we moved all over. But right now, it's come down to simulation and analysis. I've been a field tester for Moon Express for a number of activities, but my role now is to make sure that I support the engineering teams with analysis and simulation. My primary one is creating the propellant management device to stop the vehicle's fuel tank from sloshing. I did these simulations to demonstrate that there's no way we can have free surface slosh in our Moon vehicle toroidal tank. I wanted to scare people because we have a very small window that the CG can migrate, and this was to demonstrate that I needed to make bladders, I needed to make positive expulsion devices that cause this not to slosh. Some CFD analysis on some manifolds, some overbody analysis on our test vehicle because it's flying in an atmosphere. So actually, the thing about the moon is that some of the physics on the moon are so much easier than on Earth. I mean, if you can take a high school student and say, hey, I'm going to launch this thing on the moon, how far does it go? There's no aerodynamics, there's no turbulence cascades, there's none of that. So that student can tell you how far this ball is going to go on the moon. So there are some things about the moon that are easier than on Earth. And aerodynamics on Earth is a problem. You have those lake-driven snow events. That's aerodynamics, that's fluid dynamics. That's anyway, watch my mouth. Okay, so we've done some composite, because we're building this composite toroidal tank, we found that we're building a winding machine that wraps the tank. And it turns out that in a toroid, on the inside diameter, it's about 1.5 times the stress as on the outside. Well, it turns out that as you wrap a toroid, you have overlap on the inside versus the outside. Conveniently, that overlap balances. So these are the same conditions with, you can see high stress on the inside and it's balanced on the left. Let's see. So the other thing I do is I do advanced projects. The one I'm really, really excited about now is this advanced R&D project called Dreamcatcher. So we're working with a industry partner who builds those simulation and engineering tools to do evolved design to optimize brackets. So for example, I said mass is everything. Well, any mass that I carry as part of my spacecraft is overhead. It's mass that I can't sell as payload. So if I can, for example, take off 50 or 500 grams from every bracket that holds the pods, that's 2 kilograms of payload that I can sell. So I need to do that everywhere. Everywhere there's a bracket, and everywhere where anything connects, I need to optimize it. And they're creating a tool that is going to be, I feel, the future of design tools. It's hard for someone who's a CAD engineer or somebody that builds CAD because you don't build the geometry. You define the problem. And then it generates thousands of geometries, and you don't actually know why and which one is why, what's going on, but you can down select of the eventual properties. And so it's really cool. I do outreach things. This is me with Bob and Naveen trying to convince people to give us lots of money by talking about how passionate I am about the moon. I go to X Prize events, which they, as part of a Google Lunar X Prize team, there are summits that you have to go to and meet all the teams. The shirt that I was just wearing before is the German team. These global teams are the coolest people who are working so hard to get to the moon also. And the nice part is they're all chasing us, and they're all running as fast as possible because they think we're in the lead. And some of them are running really fast, and it's really exciting because I am a competitive racing person, and I am aware that some of these people are running really fast. And it's cool because I like competition. Something I'm glad I didn't show the McGill rover, but I participate in the Lunabotics, which turned into the resource mining competition. It's a really cool event that I think Western should participate in. Basically, you build a robot, you have to dig and collect regolith, dump it in a bin. It's all teleoperated. I will be a lunar regolith judge this year, so it's a really exciting event. Colleges from all over the world participate. It's like a FIRST Robotics, but for planetary exploration. And then I work with industry partners to try to find really valuable technologies and methods of doing things and bring them in-house, or even just people. So conveniently, they had the America's Cup races in San Francisco this last round, and I made some connections with the Oracle Group because they made the most advanced composite sailboat in the world. And I figured if we're building a spacecraft going to the moon, we can learn from them that built a spacecraft that sails on the water. So that's part of my role. And then I really try to drive future ideas. So for example, there's all sorts of infrastructure planning tools that exist to be able to sell, well, I'm going to build a bridge instead of a tunnel, or I'm going to go around the lake to this side instead of building a whatever. Why aren't these tools set up to do infrastructure on the moon and other planetary bodies to be able to sell programs? They're not being used for that right now. So that's one of the things I'm trying to incorporate and bring into our company and say, look, if I can show you the next 10 years of what we plan to do in setting up foundations and establishing ports, I'm going to show you through tools that people are already doing that for showing how to establish ports on Earth. And then, it's appropriate, adventure time. I'm going to go to one video before I start this, but I'm impatient. I'm not willing to wait for a ride to the moon or to Mars or to space. I'm spending every day I possibly can exploring. Even coming to London, Ontario, it is an exploration coming here. I've never been here. I've never taken 2 laps around the airport to get out of customs. I mean, it's such a tiny airport. I walked so far. Apparently, I brought the sun with me because my entire backpack is filled with winter gear to stay warm because I thought it was going to be freezing. So this is an exploration. Every time you go anywhere, you can treat it as an exploration and make a sort of daily analogous mission. And that's really powerful because how are you going to bring people to other planets if they don't have a mindset of exploration and adventure? You can't do it. So like some of the team we talked about, the grad students today, they went on this awesome adventure to the crater, I don't know the name, but way north. And that is just as equivalent as going to another planet. I mean, it's this planet, but it's awesome and it's really cool. This is part of the evolved structure thing that I was talking about. This is just an example they did with a bicycle, but the computer didn't know that there's a bicycle. It had no idea. They just defined, these are the attachments, these are the loads, these are the places to not build geometry, and it built thousands of bike frames that look like bike frames. I mean, I don't have that one, but I have one that looks like that. And so, I mean, it's doing the FEA analysis, and so I'm really excited about the future of this stuff in building structures for spacecraft. And especially, most spacecraft, the hardest environment is launching off of Earth. If you're building spacecraft in space, trust me, the structures will look very, very different, and they'll be a lot less massive. So, adventures. I try to fill my life with adventures like this one, and thank you for inviting me. So, at all levels. So I recently started scuba diving, which scares me more than some of the rest of them. But scuba diving, you go down, and you can explore the oceans. Sailing, you've got lots of water to explore everywhere the water touches. Paragliding, oh, it kind of got screwed up. So in the United States, you can only paraglide to 17,999 feet. And that's because at 18,000 feet, Class A airspace starts. But that doesn't mean that a non-powered aircraft can't go above that. In the Himalayas, people have gone over 6,000 meters, 6,200 meters in these basically bedsheet and dental floss aircraft. I've done a balloon experiment now with Moon Express up to 100, and I did this all in kilometers for you guys, but to 135,000 feet. And then the next one that I haven't been yet is the moon. So trying to expand my horizons in all directions. So my advice is to go out and explore the neighborhood, because it's this planet, it's other planets, it's nearby planetary bodies, asteroids. There's so much that we don't know, and we are slowly getting the ability to go and find out. And that's really, really exciting. So I have a couple words because I thought it was going to be mostly students. But so most of the time, the worst answer that you'll get is no. And actually, if you don't ask, the baseline answer is already no. So there's nothing to lose ever in just asking for something. This has been the most important lesson that I learned in ever, actually, because you might as well ask. There's no hurt in asking. So if you want something, if you want to do something, you're passionate about something, you even have a small idea of something that might work, you may discredit yourself for the next 45 minutes, but you might as well ask. Because you really have nothing to lose. And then the next one is PPP. This is a number of people have had this, but I had this mentor that's flying, and he's basically like Yoda. He's this short little man, he's bald, he's got pointy ears, and he says like dreamy stuff like this, and it's patience, persistence, and positive outlook. I like to say positive optimism, but some people cringe. And this is just a mantra that whatever's happening, if you're patient, you're persistent, and you have positive outlook, just keep going, right? Just keep going, and eventually something might connect, and then you can leverage whatever happened. But that was pretty important. And then cherish being a student, because well, in the U.S., when you're not a student, you have to pay back loans. Everywhere else, you have a lot less to pay back. But as a student, people will pay for you to do things. People will pay for you to go to that crater. People will pay for you to go to the Astronautical Congress. People will pay for you to go pretty much anywhere you want, so you should just ask. And so right now you have this unique opportunity as a student to do whatever you want and have other people pay for it, which is always cool. And then I want to thank everyone because this was totally unexpected. I'm really honored to be here, and I really enjoyed touring all the labs this morning. I think that's kind of my favorite thing to do, because I tried to connect with the projects and understand them, and there was one that was really, really in-depth and pretty hard to understand, but I think at the end I unlocked it, and it was cool. It was really cool. So thank you, Western, for inviting me here to give this keynote on your inaugural Space Day. And hopefully all of you become life explorers and take each day and just take a different road. Make a right when you're supposed to make a left. Just do something to hijack your brain and explore, because you'll discover something. And you might discover something about yourself that you don't like taking turns when you're not supposed to. You'll discover something.